Hello everyone, welcome to A1 Tutor Live class and welcome to physics class. Welcome to physics class once again. Okay, so the other time we started a topic which is elasticity, and in that class we're able to make justice to the concept behind elasticity, and we're able also to differentiate between elasticity and plasticity. We're able to differentiate what exactly is the difference between an elastic material and a plastic material. We said that elasticity has to do with the ability of a material to be stretched or compressed and still regain back its original shape or size. While plasticity, it is an ability of a material to be stretched or compressed, then it cannot regain back its original size or shape. So that means elasticity has to do with a temporal change in size or in shape, while plasticity has to do with a permanent change in size or in shape. So we discuss also the examples of elastic materials. We went ahead to discuss the Hooke's law, which we also did some calculation on it. So perhaps you had no chance to join the class for the previous class we had. You can do well to still watch the video on YouTube. So all you need to do is to search for A1 Tutor on YouTube, and you're going to have the list of all the topics we've done so far. There you are going to find elasticity 1. Elasticity 1. Today we are going to take elasticity part 2, and part 3 will be the concluding part, which will be the next class that we're going to have. So to save yourself of stress, to know when we upload video or when we are not uploading video, I will suggest that you subscribe to our YouTube channel. Just click the subscribe button when you get to YouTube. Search for A1 Tutor and click on the subscribe button. You are going to be getting notifications of when we upload our videos. You're going to be receiving notification as soon as we upload our videos. So you will not need to be actually missing any class or probably not getting updated videos of our classes. So just subscribe, and also do not forget that the more you share our videos, the more people get to what benefit from it. So do well to share our YouTube link on your status and also with friends. Do well also to like and comment. Most of our videos, we have an open session for you to ask your questions on YouTube. Okay, so if you watch any of our videos on YouTube and it's not clear to you, or you have some questions you want to ask, or you want to make some reviews, do well to drop your comments in the comment section. So today we are taking another subtopic under the topic elasticity. We are taking another subtopic under the topic elasticity. And with me here, we have a picture on my screen that explains or that depicts a tension force. Tension force. Now, what do you understand by the word tension? You know, I can have a rope of this nature, right? Now, when I stretch this, if this is actually an elastic, of course, there will be an extension in the length of this particular material. So what I've applied is called a tension force, pull and push. Okay, so you can see that we have two person. We have two person. Let's say this guy. Let's say this guy is pulling. Okay, let's say this guy is pulling, while this one is also pulling to his own side. So you call it a pulling what? A pulling force. Both individuals are trying to pull it to their what direction. And by so doing that, there will be an extension in the length of the rope or in the length of that material. Are you getting it? There will be an extension because the material will be stretched. The material will be stretched. So in that process, there will be an extension in that material. So that is where we have the topic tensile stress and tensile strain under Young modulus. Okay, this is going to introduce us to Young modulus that talks about the tensile stress and the tensile strain. The tensile stress and the tensile strain. We are going to define both terminologies, the tensile stress and the tensile strain. Then we are going to look at how to express it mathematically because we'll be using it to solve questions. We'll be using it to solve questions. So I want you to follow me attentively. And if you have questions as the class is going on, do well to drop it in the chat box. Do well to drop it in the chat box. I need your active participation for today's class so that we can all move on the same pace. Thank you. If you are with me and you are ready for today's work, please thumbs up as we're about to start the class fully. If you are with me and you can hear me, thumbs up. We're about to kickstart the class properly. This was just an introduction to today's class. I'm waiting for your reactions. Thumbs up. We're about to kickstart. I want to ensure that we are all following. Okay, thank you, Adeyemi Peter. So let's proceed now. We want to take the definitions of Young modulus, the definition of tensile stress, the definition of tensile strain. Okay, so now let's go to have the definition. I'm going to stop presenting my picture. So we have the definition on the board. We are talking about Young modulus today. Young modulus. I've told you earlier that in science, when you actually create a law or you propagate a law or you do a particular theorem, your theorem can be named after you, your law can be named after you. So when you hear the word Young modulus, it has to do with that probably the name of this person is Young. So to make it to be like he's actually bearing his name, using it in the field of science, so they can call it Young modulus. So if probably the person was named Divine, it can be probably Divine's modulus. So they always use the name of the scientist that actually propagate a law or actually gives a theorem to name those theorem and those law. So don't be disturbed with the name Young modulus. It actually be the name of the scientist. All right. So let's have the definition of Young modulus because we have a lot of calculation to do on this topic. And if you follow attentively, you are going to get it easily. So what is Young modulus? Let's have the definition. We need to start from tensile stress and tensile strains. Okay, so let's start with tensile stress as the first definition. Tensile stress tensile stress and tensile strain. That is what we are going to consider under that topic. As I've given a length of wire, the length is L, and a cross-sectional area, L to represent the length, and A to represent the cross-sectional area. If the wire is extended through by a force, if the wire is extended by F, that is a force, the tensile stress is defined as the ratio of the area. The ratio is defined as the ratio of the force to the area. Now, let me explain that again with what I actually explained initially. I said if this is a wire, okay, and I'm stretching this, I'm applying a force to stretch this wire. And like I said, there will be an extension to this. We're definitely going to have an extension because I'm applying a force to stretch it. Now, when you look at the shape of a wire, it's kind of circular, right? And that is where we have the cross-sectional area, from this definition. The length has to do with how long the wire is, then how it gets to be extended after applying force. Now, the cross-sectional area has to do with what? The shape of the wire. The shape of the wire is more like a circular shape. So the cross-sectional area we are talking about is the area of the circle. The area of the circle. So we call it cross-sectional area. Cross-sectional area. So there will be a force to be applied before this can be extended, and also the length of this particular wire is going to what? Increase. Is going to increase. And that is the extension we are talking about. Okay, now let's proceed with our explanation. So if that is the case, they gave us that the tensile stress is the ratio of the force to the area. So we have ratio of force to the area. Ratio of force to the area. You know, when I talk about the area of a wire, I'm talking about the what? The circular form of it. And you can actually relate this that the thickness of a wire is determined by the cross-sectional area. The thickness of the wire is determined by the cross-sectional area. And the thickness of the wire also determines how it can be stretched easily. If a wire is very thick, it will require a lot of force to stretch it. And if a wire is not that thick, it won't require much, it won't require enough, probably it won't require a large quantity of force to what? To stretch it. So the thicker the wire, the more the force you apply. The thicker the wire, the more the force you apply to stretch it. And the lesser the thickness of the wire, the lesser the thickness of the wire, the less the force you are going to apply to stretch it. Are you getting it? So that is why the tensile stress is expressed as the ratio of the force to the area. The ratio of the force to the area. It's just like you are saying the ratio of the force to how thick the wire is. To how thick the wire is. So if ratio is also division, that means tensile stress is equals to force over area. Tensile stress is equals to what? Force over area, which is represented as F over A. Now take note, force is measured in Newton. Force is measured in Newton. So if I have force to be measured in Newton, I'll have Newton here over the area is measured in what? Meter square, not meter, but meter square, because you are dealing with area. And anytime we work a calculation area, we are mostly dealing with two dimensions, and that is why we have square. If you multiply a dimension, another dimension, that will give you a meter square. If it is centimeter you are working with, you have centimeter square. But in physics, the only unit accepted for length is meter. So even while we are solving questions, take note, if I give you the length to be in centimeter, you have to convert it to meter. If I give you the length to be in millimeter, you have to convert it to what? Meter, before you can solve the question. All right. So the meter, the area is measured in meter square. So this now, if you have Newton divided by this, following the law of indices, you are going to have meter, you are going to have Newton per meter square. Follow the law of what? Indices. You're going to have Newton per meter square. Can you see that you don't need to actually memorize the units in physics? Once you know the unit of each quantities that you are working with, you'll be able to derive the unit. So this is a derived unit. Is a derived unit. Okay. The first topic that we did in February, we are talking about derived units and what fundamental units. So this is a derived unit. So tensile stress is measured in Newton per meter square. Newton per meter square. Newton per meter square. Okay, tensile stress is measured in Newton per meter square. Take note where this area is equals to pi r square. I told you we are dealing with a circle. The wire has a circular shape, so it is a circle where your pi still remain as 22/7. Okay, in some cases you are going to be given the diameter. Of course, you should know that diameter is 2 times the radius. So if I want to get my radius, it's going to be diameter divided by 2. So these are the kind of questions I'm going to solve today. I'll be twisting the question according to the UTME syllabus. That is how questions do come. They are not straightforward, they are twisted, but they are very simple. Okay, if you are with me and you are following and you understand the tensile stress, please kindly signify with your emoji as we are going to take the next definition, which is the tensile strain. I need your reactions. The tensile stress, if it's clear to you with all this explanation. Okay, thank you, Eniola. Thank you, Peter, for always being active. Like I said, I need our active participation into this class so we can move on a faster pace. All right, now let's take the tensile strain. I want you all to screenshot this because I'll be wiping off the board now. So you will not miss any part of it. Just screenshot. If you have done that, you can just give a thumbs up. So we move to the next one. Am I permitted to wipe the board? If yes, please kindly react so we can move on to the next. Okay, thanks for your reactions. So let's take the next one, which is the tensile strain. The tensile strain. I'm going to clean the board so we can have that on the screen. The tensile strain. I believe the board is clear enough now. The tensile strain. So we are going to define the tensile strain also. The tensile strain. Let's see what is the definition of the tensile strain. We are proceeding. We are moving on to the tensile strain. Okay, so the tensile strain the definition is given here. All right, so let's now examine the tensile strain. The tensile strain is defined as the ratio of the extension is E, to the original length, which is what L. So the tensile strain has to do with the ratio strain is equals to extension ratio original length, which implies that we have the extension over the original length, because ratio means division, original length. All right, which also be equals to extension is letter E and the original length is letter L. So we have this to be what the formula to calculate the strain. The tensile strain is the ratio of the extension. You know, when you stretch the wire, there will be an extension over the original length. Let's say this is a wire. I want to use my pen as a wire. Now, the original length of this pen can be probably 5 meters. All right, 5 meters. That's the original length. Now, after stretching the wire, assuming this is my wire, after stretching it, there's an extension. Okay, there's an extension. How do we get to extension? Extension is equals to the new length, let's say L new minus L original. So if I want to get extension, it means that I'm going to take the new length after stretching it, after the tensile force. has been applied to this wire, the new length can be, let's say the new length is 6 meters, and the original length, this is new, and the original length is 5 meters. That implies that the extension is 6 minus 5, which is equals to 1 meter. So the extension for this, after applying the tensile stress is what? 1 meter. So it is the ratio of the extension to the original length, which is expressed mathematically as extension over original length, okay? Which is also expressed as E over L. Take note, the tensile stress does not have a unit. So if I solve this, my answer can just be 0.4, and that is all. There will not be units. Let me write in bracket, no units. So anytime you solve a tensile stress question, there's no units. But if you are solving a tensile, anytime you solve a tensile strain question, there is no units. But if you are solving a tensile stress question, there is units. And the unit of tensile stress is Newton per meter squared. For stress, the unit is Newton per meter squared. For strain, it is no units. Okay, I mean there will not be any unit for the tensile strain. So take note of that, because WAEC is very, I mean WAEC again, the UTME bodies are very smart. They will give you a question on the tensile strain, and they are going to add units. Let's say my answer is 0.4, they will now say 0.4 Newton per meter square, maybe 0.6 meter square. They will give you questions, they will give you options with what we units. And you'll be thinking that, which one is now correct? And you will see one of the options that will stand alone, it's not having any units. So you'll not be confused. But in physics, we expected to have units in every of our calculations. Why is this question giving me an option without a unit? Of course, the option without a unit will likely be or is the correct answer, because when you are solving for tensile strain, there is no unit. Please, I want you to jot that inside your book. It's very important. When you're solving a tensile strain question, there is no unit. I believe that is clear. If that's clear to us, please, let's signify. We are moving on. We want to look at the Young modulus now. If you are with me, please kindly signify. And if you understand the tensile strain that we just explained, kindly signify. Okay, Eniola, thanks for your response. That means we can move on to the Young modulus expression now. Let's consider the Young modulus. Permit me to wipe the board, but before that, please take a screenshot of this before we wipe the board, so you have a note to actually revise later. Okay, now let's take the Young modulus. The Young modulus. The Young modulus. A Young's modulus. Okay, what is the Young modulus? Now we need to express that using our notes. A Young modulus Okay, now, considering the Young modulus now, we have to start from the Hooke's law. Hooke's law can also be stated as the stress is proportional to the strain, provided that the elastic limit is not exceeded. Stress is proportional to strain. Okay, now to avoid confusion, let's use other alphabet to represent that, or better still, write it in full. Stress is proportional to strain, provided that the elastic limit is not exceeded. Now, also we can express Hooke's law that we did in the last class, like what we have on the board now, that stress is directly proportional to strain. Stress is directly proportional to strain, provided that the elastic limit is not exceeded. You know, there's a limit at which you can have a stress. You can stretch a material. It will get to a moment that it is not going to stretch anymore. That means the elastic limit has been exceeded. If you stretch a material continually, okay, let's take the rubber band that you use. When you stretch it, it will get to a moment that it will not stretch anymore. So when you force it, it will just cut. So at that moment, you have exceeded the elastic limit. So the law says that stress is directly proportional to strain, provided that the elastic limit is not exceeded. There's a condition that the elastic limit is not exceeded. I believe you understand that. So if our stress is directly proportional to strain, and we already expressed this mathematically to be F over A, we said stress is F over capital letter A, directly proportional to the strain. We said it is extension E over length, which is L. All right. Now, this is an expression. We need to introduce a constant. And the constant we are going to introduce is letter Y, which represents Young modulus. So I have F over A. When I have equal sign there, the equal sign is going to invite a constant. I've taken away the sign of proportionality, the signs of variation, which is this sign. This is the sign of proportionality or the sign of variation. So once we take that away and we bring in an equal sign, it will invite a constant. And the constant is Y in the bracket E over L. Now, what is the aim? The aim is that we want to make Y, which is the Young modulus, subject of the formula. We want to make Y, which is the Young modulus, subject of the formula. Okay, follow me carefully. We go ahead to make this subject of the formula, SOB, subject of the formula, SOF rather, SOF. So if Y equals to, now I want to get Y. Get me very well. If I have 2x equals to 4, you are going to tell me that to get x, I need to divide both sides by the coefficient of x, which is 2. Now I want to get Y. What is the coefficient of Y in this expression? The coefficient of Y is this bracket. So I'll be dividing both sides by these brackets, and that will give me F over A over, but I don't want to use over. I'm going to use divided by E over L. Divided by E over L, which is also the same thing as saying F over A all over E over L. So Young modulus is given as F over A all over E over L. So that is the formula of what? Young modulus. And we are going to be using that to solve some questions today on stress and strain. I believe the way we derive the formula is clear to us. If yes, please kindly signify with a thumbs up. Thumbs up. Let's have a reaction. If the way we derived this formula, Young modulus, if it is clear to us, please kindly signify. I told you that Y is Young, the Young's modulus. The Young's modulus. Okay, thank you, Eniola, for that response. Okay, do we still have more reactions? Or if there are questions, don't forget that you are free to drop your questions in the chat box, okay? Drop your questions in the chat box. Now, if you have all gotten the Young modulus, now we need to dive into solving calculation. And I have some amazing questions for us to solve that will cover virtually everything that has to do with young modulus. And I will need you to follow attentively. Physics is very simple. I've always been saying that it's just for you to get the concept, know the hint, and know the trick behind it, and you are good to go. All right. So now we are going to start the calculation. But before that, let's take a pause and address our followers on YouTube. Once again, we are going to bring it to your notice that our videos are always uploaded on YouTube on daily basis. We have classes 6 times a week and we upload them on YouTube. 2 classes per day, every day. That is a whole lot of videos that we are uploading just for you to learn at your own convenience. So please, if you are not actually chance to follow the live class, that is not a problem. Do well to follow us on YouTube. And to do that, you need to subscribe on our YouTube channel. Just click the subscribe button. Okay? It doesn't bite. Click, click. Once you click and you are good to go. Once you have subscribed once, that's the end. You don't need to subscribe again and again, just once. 1 second, you are done subscribing. And for life, you'll be receiving notifications of our videos, notifications of our videos on YouTube. Don't forget, not just subscribe, subscribe, like, and share. Thank you. Now let's go to calculation. Calculations now. We have calculations to solve, and I want us to follow attentively. Calculations. We're going to take the first calculation on young modulus, and I'm going to break it down for us to understand. I'm going to break it down for everyone to understand. Calculation on young modulus. The first question we are going to consider okay, so we have a question here. This is our question. Okay, all right, so let's go ahead to solve this question together and follow attentively because I'll be asking question as I'm solving. Now, the trick behind physics is that anytime you are given a question, first look closely, critically, examine the question and bring out the parameters that will ease your solving. It will ease your solving. So let's go together to do that. A wire of length. So now you can see we are talking about a wire. That was what I used to explain the tensile stress and tensile strain. So a wire of length, you can hear the word length. So that means I have length. Length, small letter L, is 2 meter. That's 2.00 meter. Okay. Underline this is the one of the informations given. Then we have radius. Radius. So that means R equals to 1 millimeter. 1 millimeter, which is also the same thing as 1.0 millimeter. Or let's write it in full. 1.0 millimeter is stretched by a 25.0 millimeter. It is stretched by 25.0. It is stretched by. That means after the stretch, there is an extension. There's an extension. It is stretched by this value. You know, when you stretch something, what you have done is that you have extended the wire. So that stretched by is telling us about the extension, which is 25.0 millimeter. Okay, on the application of a force, you cannot just stretch a wire. You need to add force for you to stretch it. Okay, so the force F is given to be 103 Newton, 103 Newton, 103 Newton. Now we have all these informations and we can go ahead to solve. Take notes, you need to check your parameters. This is okay, we can use it that way, but this is not okay. I need to convert millimeter to meter. Then to do that, note that 1000 millimeter is equals to 1 meter. So to convert this, I'm going to do 1 over 1000, 1 over 1000. If you are with your calculator, you can do that for me, or if you can actually solve this without calculator, it's awesome. 1 over 1000, that will give me 0.001. Okay, that's just expressing it in decimal points, 0.001. So this will give me 0.001 meter. Okay, I have to convert this also to what? To meter. And that is 25 over 1000. I want someone to give me the response for this. 25 over 1000. What will be the response? Do that for me. 25 over 1000. What will be the response? I'm waiting for your response in the chat box. 25 over 1000. What will be the response? I'm waiting. Can we have the response from you? 25. You're just going to divide 25 by 1000. Awesome. Thank you, Blessing Bassi. Thank you, Eniola. That's a great response. They said the answer is 0.025. That's a great response. All right, so we are good to go. Meter. Now we have everything to have been presented like it's supposed to be. Everything is in order now. We need to go ahead to solve. Young modulus is what you have to calculate. And if I'm asked to calculate young modulus, it means y equals to stress over strain. All right. And that is the same thing as saying stress is F over A divided by strain is E over L. Now, if you check everything that you have been given, there's no area. We don't have area in the word in the question. So I need to source for area. I need to source for area. So how will I do that? I said area has to do with the circle of the wire, the circular shape of the wire. So the area is pi r square, where pi is 22 over 7, 22 over 7 multiplied by r. R is what? R is 0.001. So we have 0.001 square. So when you simplify this, 22 over 7, 22 over 7, which is also 3.142, you multiply it with 0.001 all square. We are going to have the response in standard form now, 3.1429 times 10 raised to power minus 6. Okay, if you're not writing in standard form, you'll be having a decimal expression, of course. That's 0.0000. You have like, after the decimal point, like 5 zeros before you have your values. But let's have it in standard form this way. It's going to make it easier for us to solve. I believe that is clear. So we've gotten A now. Now we can go ahead to get the answer for the young modulus. Young modulus equals to F. What is F? F is 103. That is 103 over A. What is A? A is what? 3.1429 times 10 raised to power minus 6. Okay? Divided by E over L. E over L. What is E? The value of E is what? 0.025. 0.025 over 0.025 over. Now we need to check for N. What is the value of N? 2 meter. That is over 2. Young modulus equals to 1. Sorry, this is not 130. It should be 103, not 130. Let me correct that. 103. So we have 103 over 3.1429 times 10 raised to power minus 6 multiplied by, when you change this to multiplication, there will be a reciprocal. That is, 2 will become the numerator and 0.25 will become the denominator. So there will be an interchanging in the fraction because you have changed it to multiplication. So this will be 2 over 0.025. So all we need to do is now to multiply 103 times 2, 103 times 2 over, now let's express this in decimal so we can multiply out also. This will be 0.0000. I'm trying to express this standard form in decimal, 0.000. Okay, then we have 3, 1, 4, 2. Instead of 2, let's make it 3. Okay, I've make it more simplified that way. 0.0, this is 0, 0, 0, 0, 0, 3, 1, 4, 2, 3 times what we have the denominator is 0.025. So from your end, I want you to do this for me. Multiply this and let me have your answer quickly. Multiply 103 times 2 and let me have your answer. Multiply that and let me have your answer. I'll be solving the remaining one at this portion. Y equals to, multiply 103 times 2. I'm waiting for your response quickly. Okay, thank you so much, Eniola. That's 206. Okay, also multiply the denominator for me. Multiply 0.000003143 times 0.25. This is 25. And tell me your answer. I'll be waiting for your answer quickly. What will be your answer when you multiply that? It's going to be a long decimal number. So I want to have your response. What did you have? When you multiply this denominator together, you should be having 0.00000123456, then 7. Okay, 0.00 like we have here, then we have 7, 8, 5, or let me say 786. Yes, let me say 786. I've approximated the value. Confirm this from your own end. When you multiply, is that what you're having? If that's what you're having, please thumbs up. Then the next thing you're going to do is just to divide this. You're going to be dividing this. Okay, thank you, Anila, for confirming that. So we are going to be dividing that to have the final answer. So let's divide that to have the final answer. And let me know your answer. What is the final answer when you divide? Dividing that expression. Let's know your final answer. 206 divided by 0.00000. That's how many 0? 1, 2, 3, 4, 5, 6, 7. Dividing that, we have the final answer to be y equals to 262,085,140. So this is going to be the final answer after you have divided this expression, and it has a unit. The unit of a Young modulus is Newton per meter square. Newton per meter square. So I want you to confirm that, do your division, and tell me what you are having. Confirm it with my response. If you have the same response with me, kindly confirm it. Divide 206 by this value of decimal and tell me what you are having. I'm waiting for you to confirm the response. The Young modulus is what I have on the screen. Have you done your division? What is your response? Is it in alignment with what I'm having? If yes, thumbs up. Thumbs up. We're about rounding up the class. Okay. Okay. Thank you for that. Yes. So the Young modulus is 262085. Okay. If I'm going to cut that as a whole, let's have it. So we are having this value. Yes, we almost have the same value. Of course, we almost have the same value. With what you are having and what I'm having, that should be likely the same value. Okay? Someone gave us a response of what she got, and it's kind of close to our answer. Yes, it's kind of close to our answer because we approximated each of our values. So this is the Young modulus value, 200 and 200 and okay. Yeah, you don't understand. I mean, you are dividing this by this. Latifa, you are dividing this value 206 by 0.000 that you have here. When you divide it, you are going to have that answer, okay? Okay, you just joined the class today. If that's the case, you are going to make use of the YouTube page to watch the first part of this class, which is Elasticity Part 1, and you're going to get it, okay? Watch the YouTube videos online. Search for A1 Tutor on YouTube, A1 Tutor on YouTube, and watch that video, okay? If you have any question while you are watching the video, drop it in the comment section. All right. So today, guys, we have been able to explain what a tensile stress is, a tensile strain, and also we're able to derive the formula of Young modulus, and we're able to what? Practicalize the Young modulus by solving a mathematical question on it. Okay, I'm going to leave us with a question that I want you all to work on. Permit me to wipe the board. I'm going to drop a question. I want everyone to work on that question and drop your response on the YouTube channel in the comment section once you are done solving. It's just one question under Young modulus. Okay, so this is the question you're going to be solving. So this is for you to practice. And when you are done with that, you can communicate your answer to us through our YouTube channel. Thank you for your time. Stay online. You'll be having the next class in a few minutes' time. And you will not like to miss biology class. It's fun. So ensure you are online and wait for the next class. Thank you.